Hi folks, we'll see if this works. With just me holding the cell phone. A online discussion that I'm having right at the moment with a company, I think they're based in Germany, called Microgen. And they've been for a long time developing Stirling engines as a means of generating electric power. And for those not familiar with Stirling engines, you've probably seen toys that run on them, or if you have a wood heater in your house of some kind of wood stove, you might have picked up one of those kind of expensive fans that you can sit on the stove and they'll spin just based on the heat of the stove. Well, you've got a Stirling engine. They're commonly called heat engines. More specifically, external combustion engines. Steam engines are in that category as well. And what that means, and I regard it as being very important, is that they're independent of the fuel. So, because it's an external combustion engine, meaning that you have a heat source, any heat source, on the outside of the engine, then you can use any kind of fuel. So, brush, coal, oil if you want, wood heat, solar heat, concentrated solar heat, waste heat from some other source. They're extremely flexible and secure in the sense that your source of fuel can be extremely local. In my case, I can find my source of fuel right on my own property with wood heat. What I wanted to talk about in this case is the modern notion of efficiency. And I think that's something that we need to reevaluate or expand into being more comprehensive than what you might think of as the modern considerations for efficiency. So right now we have internal gas engines, internal combustion engines, diesels, even nuclear power. That's just an elaborate internal combustion engine, if you want to regard it as such. And we talk about efficiencies there, but are they efficient? And I would suggest that in an expanded consideration, they're not efficient at all. You see, you have to, I think, now include an evaluation based on embodied energy, and that encompasses all the energy inputs required to maintain an internal combustion engine. So let's take a gas engine as an example. It won't run on just any fuel, right? It runs on gas, and a very specific type of gas, and it is an expensive proposition to make that gas. Energy-wise, gas may be relatively cheap, but the infrastructure that's required to generate or create gasoline is energy intensive, and we have to ship it all over the place. So the gas that I burn in my truck comes from some other part of the planet, and that oil gets shipped to another part of the planet, to a refinery, and then that refinery ships gasoline up to some distribution place, and then eventually gets into my tank, where I burn it up and poof, it's gone. Is that efficient? No, I don't think so. The engine itself, excuse me, may be kind of more efficient than the same type of engine from 40 years ago. In one very narrow parameter, yes, it is. But if we regard, again, embodied energy, then the engine that I have now is extremely complex compared to an engine 40, 50 years ago, which requires a complex industrial infrastructure to create and then maintain. The engine now is less repairable than they used to be, meaning locally repairable. I mean, I can buy cheap parts from China and substitute, broken parts that are on it now with those parts, but that's not repairing. That's substitution. And again, is energy wasteful. So the concept of efficiency, I think, needs to be reevaluated. And if we look at it a little bit more closely, then Stirling engines and even steam engines, I'm not talking about old ones, I'm talking about re-examining steam engines and upgrading them to modern standards of precision, which requires more energy. So again, they wouldn't be as efficient in an embodied energy standpoint as an old engine. Still, I think there's quite a lot of improvements that a steam engine could benefit from. Now, Stirling engines are kind of an interesting one in the sense that they've never gone away. They're not an old-fashioned engine. They're extremely modern. And NASA relies on them quite extensively and has for a long time. Submarines use them extensively. They've been around a long time, and they work quite effectively. In the sense of, for somebody like me, my application, I would want to have a Stirling engine and then scavenge waste heat from my bake oven, let's say, and generate some electric power from that system. No, it's not going to be as a lot of power that I would get from my diesel generator or from my gas generator, but I'm using essentially a waste product, the excess heat that gets shot up my chimney anyways, to generate some power. I think that's would be regarded as an efficient way of dealing with things. Now, there are other aspects to this, though. Because of our fossil fuel dependency and the marvelous technology that is gas engines and diesel engines and so forth, we have shaped our infrastructure and even all of our consumer products based on the availability of energy, the ready available energy, the convenient available energy from those sources, from the sources that we're familiar with. And so we've built convenient devices based on profligate or a huge amount of energy and not examining really how um, how those devices could be better designed for a less intensive energy source. So the industry that we have now is based on a very specific set of parameters and driven by that. If we look at Stirling engines as a driver of new innovation, and if we have folks who live with a reduced energy footprint, have Stirling engines in their homes, generating some power, but not as much as they used to, then that could generate a new um, set of industrial innovations, making better toasters that fit in with the energy footprint, or the reduced energy footprint. Fridges, stoves, uh, maybe not stoves so much. Maybe, who knows? But I think they could look at this more closely as a driver of a new set of industrial innovations. Who knows? A point that I forgot to make, a major point, I think, with regards to Stirling engines, and this applies to solar and wind energy uh, electric generation, is that each of these is trying to fit themselves into our current way of life, our current very intense energy footprint, lifestyle, if you will, although I don't like that term. And I think that's a mistake. Uh, Again, it's like I had mentioned earlier in the video, we need these technologies to be drivers of a different kind of innovation rather than trying to accommodate a lifestyle that's no longer sustainable. And my criticism of an awful lot of majority of environmentalists is that they want to have their cake and eat it too. They want to maintain the lifestyle that they have and also do it all by solar and wind energy. And that's not possible. Check the physics. Thanks.